Hello everyone, welcome to our video presentation. We are from Team JNEC. Our team information, we are Team JNEC from Geminamical Engineering College, Deotang, Samsongar, Bhutan. Bhutan's introduction into the field of space technology is a manifestation of His Majesty the King of Bhutan's pragmatic and foresighted vision to establish the foundation of his aspiration of a future that is technologically independent. Now let me introduce our team members. Ms. Srijana Kashmir, she is our project manager and technical advisor. Mr. Vivek Subba and Ms. Sangeetima, they work on hardware testing and design. Mr. Balkrishna Pradhan and Pasang Tsering, they are working on the communication subsystem. Mr. Abhishek Prokril, he works in electrical power system. And for the payload subsystem, we have Jiwan Thapa, Dawat Tsering, Purba Wangchen and Ugen Thile. And for the command and data handling system, we have Pravin Guru. The entry of Bhutan into landscape of space technology is a realization of pragmatic and prescient view of His Majesty the King of Bhutan to lay building blocks towards an ambition of technologically self-reliant future. The seamless transition into now a space-faring nation with the launch of Bhutan 1, the country's first satellite was materialized through Birds 2 program. The team majorly comprises of university students and is motivated to design, develop and operate a payload using the ground station infrastructure and the resource located in the college campus. Birds X APRS payload design competition is an excellent avenue for Bhutan to elaborate in teamwork, integrate theoretical and practical knowledge of engineering subjects and develop real-time payloads which would take formative steps towards emerging space education in Bhutan. To work in a project as one would empower current university students and set a precursor to culture of space hands-on education which would contribute to progressive research, development and application in the country. As space education is relatively new and technology surrounding it evolving, participation and launch of a payload from global platform provided by Birds X project is going to inspire generation of young Bhutanese students, engineers and scientists to work his dream of technological self-sufficiency. The college acquired radio communications amateur license for the operation of ground station from Bhutan Infocom and Media Authority BIGMA in 2022 and has established operational ground station in the college premise. The ground station is managed and operated by students and have been able to perform APRS Jupiter operation, receive data from NOAA satellites and track general amateur satellites regularly. The ground station has been instrumental to conduct real-time practical demonstration and has catered to enhancing learning of students in the college. With the participation and utilization of Birds X Project Pulse, the ambition to develop in-house payload for catering educational purposes and maximizing the utility, the ground station is foreseen with great aspiration. Students would be engaged in payload development, enabling an extension to real-time project development, participate in operation and observation of the payload from the college ground station, and set an unprecedented benchmark in the college to participate in similar and bigger projects. The mission of the project is to design and develop an APRS Jupiter payload using off-the-shelf components and augment a radiation sensor which will be able to measure space radiation. The APRS payload is designed to work as an APRS repeater, allowing the communication in remote or inaccessible areas and when needed to store and forward APRS packets coming from the ground stations. Alpha, beta and gamma radiation sensor as the primary mission sensor will measure space radiation parameters while its course of orbiting the Earth and periodically downlink the received data using FSK modulation. This ultra-low power radiation sensor data can be used by researchers around the world to plot radiation maps, identify solar flares and calculate thickness for the materials used for the radiation shielding. Exposure of humans to the harmful space radiation environment in low Earth orbit and beyond poses one of the significant hazards to long-term space habitats. Space radiation has effects on human DNA, cell, and tissues. This is largely due to the increased ionization that takes place near the track a particle of space radiation takes through a material. Hence, it has become important to determine the amount of space radiation and develop methods to mitigate those risks. The project team is equipped adequately with the platforms, labs, and human resources for advocating amateur radio and APRS technology to national and local community. An existing ground station facility based in the college currently caters to infrastructure, communication and antenna backbone, network and working community structure to operate and monitor the payload after launch. Interestingly, there is no amateur radio, ham community and policies of framework surrounding establishment and operation in the country. JNEC aspires to establish the country's first amateur radio community and bring on board policy makers, students and enthusiasts to establish the foundation of the successful ham community. Since space technology and satellite is a relatively new concept in materialized and accessible form for Bhutanese population and especially to STEM enthusiasts, through the initiative of this project and as a lifelong commitment, the team aspires to execute its plan through the following goals. Number 1. Advocacy and awareness program. A prerequisite action plan would be in advocating and spreading general awareness on APRS and amateur radio concepts, fundamentals of satellite communication technology and basic principle of operation and possible application of the mentioned technology. The target group would be middle schools, high schools, college students and public. Radio and communication have always been readily accepted technology in Bhutan. With people of all ages, amateur radio can also be explored in conducting two-way communication for exchange of culture, values, establishing friendship among base stations and users, sending the emergency signals and messages, technical or general information with other ham users anywhere in the world. The fun and unexplored possibility of ham radio communication could be advocated in related format for the general public, slowly progressing to the technicalities and engineering aspect to it. Number 2. Boot camps and workshops. Tailored boot camps and workshops on basic operation of ground station, demonstration of satellite communication, interfacing of basic sensors with microcontrollers can be offered to students of the mentioned targeted group. Number 3. Curriculum integration and adaptation. JNEC offers satellite communication as a model for development program and weaving curriculum around basic design, prototyping, launch and operation of small payload could serve continuity and progress of this subject matter, also weaving ground station and ham radio operation and application to the future graduates and more. Number 4. Digital education space exploration. Apart from the conventional education through classroom and lab setting, space and satellite education can be served and catered to general public and students through the digital and social media spaces like Instagram, YouTube, Facebook and a personal web page for the same. Number 5. Events, seminars and conferences. To ensure continuity of outreach initiatives and to establish collaboration with relevant stakeholders, events such as seminars and conferences on emerging space programs and real-time research and progress on satellite technology can be fulfilled. Number 6. Internships and labs. Existing infrastructure and state-of-the-art labs can offer internship opportunities to enthusiastic students on small payload development, monitoring and other aspects of communication engineering. Number 7. Research, record keeping and resource repository. Study and research materials pertaining to this subject would be collected in various formats. Digital data logging and record keeping would be maintained to ensure passing on to the future users. Data acquired from the payload can be stored and logged with our role as a national repository, which can be accessed by scholars, researchers, government agencies, and relevant organizations for ethical study and research. Number 8. Manuals and publications. Development of small payload, data maintenance and utility, a ground station maintenance and operation would be documented in the form of procedural manual for transparency and accessibility for future research and development. Number 9. Podcast and storytelling. To reach out the advocacy program contents and current affairs in the space technology sector to the local community, JNEC FM radio station, which is a community radio station in the campus, can be used as infrastructure. The program can also be hosted on national radio, television programs and through the print media. Through the art of storytelling and podcast over FM radio, students can impart information through a much accessible format for locals. Number 10. University to school monitoring programs. As an initiative to bridge program between university and school education, a mentor-student ecosystem can be established between team engineers and school students over educational assistance and vocational and hands-on training. The payload will act as a digital amateur radio repeater. Operators will be able to upload a message to the payload and it will transmit it to the ground on the successful reception of the packets. This will act as a short message repeating system. The payload will help in the measurement of space radiation while orbiting, and the measured radiation level can be downlinked to the Earth. Amateur radio will be able to receive and decode the radiation measurement data. Payload collects the data from the radiation sensor, stores on board and transmits to the main station. The sensor measures the alpha, beta and gamma radiation around it and transmits the data to the ground station. The payload will transmit its identification and health parameters of the satellite in Morse code. Payload also transmits the intensity of the radiation of the orbit along with the other telemetry of the satellite. The payload data and housekeeping data are transmitted using FSK modulation and CW mouse beacon. The intensity of radiation can be used to plot the radiation map, calculate the thickness for the radiation shielding materials, identification of solar flare, and etc. When the ground station sends the active command to the payload, the radiation sensor will collect the radiation data such as alpha, beta and gamma rays and forward the data to MCU. Then MCU will store the data to the flash memory. Then the data will be also transmitted back to the ground station. To communicate between the two ground stations, the first ground station will send a package to the payload, and with the help of the digipeater, the packets will be forwarded to the second ground station. Thus, the communication will establish between the two ground stations. This is the timeline of our mission, and by the end of December, we'll be able to complete our project with the submission of our FM board. Thank you, and this is the end of our video presentation from Team JNEC.